Welcome back, students. Today we're going to be talking about doing function operations with multiplication and division. All right, so in this first problem we have got h of t and there's g of t. And then down below here's our problem that we need to do h of t multiplied by g of t. So what I'm going to do is begin with some substitution. So h of t is equal to a 4t plus 5. So here in parentheses, I'm going to do 4t plus 5. Then we saw that multiplication sign. I'll go ahead and put that in right there. And g of t was 4t plus 3. So I'm just replacing each function with what that function was equal to. All right, now in this next part, we need to be able to perform this multiplication. This multiplication is going to look a lot like the distributive property you've done before, where we would multiply this number outside of the parentheses by both of the numbers on the inside. Okay. However, notice over here in red, we've got two terms that are multiplying the two terms inside of those parentheses. So we are going to first start with that 4t. And what's going to happen is we're going to, same kind of distribution up here, we're just going to multiply this red 4t by both of the terms inside the blue parentheses. So 4t times a 4t would then give us 16t. Oh, sorry, 16t squared, because there were two t's. And then 4t times 3 will just be 12t. Okay, next we also have the 5. So we can't just multiply the 4t through. We also need to multiply the 5 through. And we're going to do it to both of those as well. So 5 times 4t will give 20t. 5 times 3 is a 15. And now all we need to do is combine like terms. Like terms are going to have the same variable to the same power. So yes, we've got that 16t squared, but because it has an exponent of 2, that means that we can't just multiply, we can't just combine it with these others. I can't do 12t plus the 16t squared. So the 16t squared is going to stay separate. However, 12t and 20t, same variable. Both of them are to the power of 1. So we can combine those to create 32t. And then we have the 15. There we are. We're done. We found our final answer. That is h of t times g of t. Let's go ahead and do that again. So we got h of x, g of x, and they want us to figure out h times g of x. So let's go ahead and start that. H of x is once again just going to be negative 2x plus 1. So I just did the same kind of direct substitution from last time. G of x is equal to an x squared minus a 3. Now we're going to begin that same distributive multiplication that we did last time. So negative 2x times an x squared, we'll have negative 2, and then x times an x squared means we now have 3 x's that got multiplied together. So we got 2x squared, and then negative 2x cubed, sorry. Negative 2x times by a negative 3 will give positive 6x. Now we can multiply through the 1 to both of those. So 1 times x squared will give us x squared. 1 times negative 3 gives us a negative 3. Now, that's pretty much done. We don't have any like terms that can be combined. We've got an x cubed, there are no other x cubes. We got an x squared, no other x squareds. We got an x, there are no other x's. and we got a 3, which is just a constant number. There are no other constants. So that's pretty much done, except for one thing. There is a math convention, which is just kind of an agreed upon way of doing things. So some old dead math guys decided whenever we write expressions such as these, we want to put the variables in descending order of degree. So here's what that means. I'm starting with my biggest exponent, and then this squared was the next biggest, so I'm going to put it next. Then we'd have the 6x, and then the 3 didn't even have a variable, so it goes last. So our exponents are going 3, 2, 1. And that's just the order that we want. The biggest ones first, down to the smallest. And we're done with that. All right, so we just did 2 multiplication problems. Now let's go ahead and do 2 division problems. We got our f of x, we got g of x. We've got f over g with an input of x. So those equations aren't going to change much, so that's just going to be equal to, let's put the f, 3x minus 3, over the g, 4x plus 5, and we're done. Okay, there's really not much more to that. If I saw a number that I could divide everything by, great. Do that, simplify the fraction. There's just nothing there for us to simplify, though. So we're going to leave it there like that. All right, in this next one, there's our h, there's our g, and we're going to do h of t divided by g of t. Now, right off the bat, I'm going to make a slight switch here. At this point of mathematics, I'm not a huge fan of writing division like this. It has its uses, and I'm not going to say never ever use it, but for the most part, fractions are the useful way to divide. They are the more efficient way of writing division, especially as we start getting into complex algebraic functions that involve division. So I'm going to rewrite that statement as h of t over the g of t. Okay, and that's a bit of personal preference. If you don't do that and you write our substitution out and you use that division symbol, you're not going to break anything. But I would say that as you start going higher up in algebra, it is worth it to get used to drawing all of your division as a fraction. So I've replaced h of t with 4t plus 1, and I'm going to replace g of t with t cubed plus 3. I don't see anything that both are divisible by, so great, that fraction is done. In these next problems, there is going to be a slight change. The input is changing. So here we've got an input of 10, an input of 8. So what these statements are literally going to be saying is we're going to have negative 5 times f of negative 10, or sorry, not f. First, that problem up above had g. Then we have the minus 5 multiplied by f of negative 10. So notice this negative 10 is just the input for both of those functions. Now, before I start writing all that out, it may be a lot easier to just go ahead and figure out what both of these things would be. So let's figure out what g would be. So if I do g of, then we do negative 10. So g of negative 10 is going to equal to 2. And just like I replaced this x with a negative 10, we're going to replace that x with a negative 10 plus 1, which should equal 19. Okay, so there's our answer. G of negative 10 is a 19. Okay, next we've got F. So we want to do F of negative 10. That's going to equal a negative 10 plus 4, which equals negative 6. Oh, and I did make one mistake up above. Sorry, that should have been negative 19. All right, so now we know what G of negative 10 is and what F of negative 10 is. So we can go ahead and put that into our statement down here. So negative 5 times by G of negative 10 was negative 19, minus 5 times F of negative 10 was negative 6. And I'm just substituting in the values I found in the step above, where I substituted in the negative 10 that they gave me. All right, so negative 5 times negative 19, I get a 95. And then negative 5 times negative 6 would be a positive 30. So we get 125 for our final answer. All right, let's do another one similar to that. So once again, they gave us a new input. We've got our two functions, h and g. So right here we have h. What I'm going to do is substitute in that 8. So we're going to have h of 8 is going to be equal to an 8 squared minus 3 times 8. All right, well, that'll be 64 minus 24, which is just 40. All right, so we now know what h of 8 was. Let's go ahead and figure out g of 8. So g of 8 should equal to a negative 8 plus 4, which is then just going to be negative 4. All right, so in our problem, we had 3 times h of 8. Now h of 8 was just 40, so that changes to 3 times 40, plus, then it had g of 8. Well, g of 8 just equaled negative 4. So now we do 120 plus negative 4 will equal 116. And there we are. So remember, all we need to do, if they're giving you this input number, put the number in, figure out what the output would be, and then you can use that output to find your answer. All right, let's do it with some division ones. But hopefully, at this point, you're noticing how this repeats. It's getting very repetitive at this point. So we've just got h of 9. So up here, I'll do my h of 9 is equal to 9 squared minus 2, which should equal 81 minus 2, 79. All right, so I know what h of 9 is. Now let's go ahead and figure out what g of 9 is. That'll be a 9 minus 3, which is 6. So we know h of 9, we know g of 9. So this statement right here is going to become 79 over 6. I don't see a number that both of those are divisible by, so I'm done. All right, and again, we've got h of n, we've got g of n, and we've got an input of 2. So we now need to put that 2 in for both of these. So h of 2 is going to equal negative 4 times 2 minus 1, which should be a negative 9. And now that we know h of 2, we just need to figure out g of 2, which should be 4 times 2 minus 1, which equals 7. And now to substitute that into our equation, we're going to have h of 2 divided by g of 2, and we're done. Okay, so that is substitution, or that's evaluating functions for a given value. Now, this next part is going to up the difficulty a bit. The way in which it ups the difficulty a bit is our input is no longer just a number, and it's no longer just x. When it's just x, we don't change the function at all. In this situation, we've got an expression. We've got a mixture of variables and numbers put together. But the process that we've been doing is largely going to remain unchanged. So just as before, here I have g of negative 4n, so I got to figure out what that is. So g of negative 4n. And now wherever I had my x in my problem, I'm going to replace it with negative 4n. And I just need to evaluate for that. So 4 times negative 4n will be negative 16n plus 4. All right, so I now know what g of negative 4n is. And that's all you're doing. Replace your x with whatever they put into the second set of parentheses. Whatever they put into the second set of parentheses, that's your input. Okay, so our input here was negative 4n. Put the input in the place of x. And now let's do it for h. So h of negative 4n should be equal to a 3 times negative 4n cubed minus 5 times negative 4n. Well, there's a problem. All right. First, let's deal with this cubed. Both of these are being cubed. So negative 4 cubed is going to be negative 4 times negative 4 times negative 4, which equals a negative 64. N cubed is n times n times n, which is going to simplify just into an n cubed. Negative 5 times negative 4 will give us positive 20n. And now I can perform that last bit of multiplication. And 3 times negative 64 should be a negative 192 n cubed plus 20n. All right, so let's go ahead and make our fraction. We need to do g of negative 4n over h of negative 4n. So g of negative 4n was negative 16n plus 4. H of negative 4n was negative 192 n cubed plus 20n. Now this problem is unique among the fractions that we've seen because this one can simplify. So we ask ourselves the question, what is the number that all of those are divisible by? So one thing you could say is 2, but the largest number they are all divisible by is 4. So to simplify this, I do that. We divide every single term by a 4. Or in other words, we're factoring it out. So that'll become a negative 4n plus 1 over negative 48 n cubed plus 5n. And there's our simplified fraction. We're done. All right, final problem. We now have g of x, h of x. We're going to do g. Oops. We're going to do g times h of negative 3x. So g of negative 3x should be equal to a 3 times negative 3x minus a 2. And that will simplify into negative 9x minus 2. Next we've got h of negative 3x should be equal to 2 times negative 3x minus 2, which will simplify to negative 6x minus 2. So now we know what g of negative 3x is and what h of negative 3x is. They want us to multiply both of those. So g of negative 3x was a negative 9x minus 2. And we are going to multiply that by h of negative 3x, which was negative 6x minus 2. And now we're going to do the multiplication that I showed in the very first problem. We can do negative 9x times negative 6x and get 54x. Negative 9x times negative 2 becomes positive 18x. Now the negative 2 will get multiplied to both. So negative 2 times negative 6x will become positive 12x. Negative 2 times negative 2, positive 4. Oh, looks like I did make one mistake. Negative 9x times by a negative 6x should have been 54x squared. We multiplied two x's together. So because that one's an x squared, it cannot combine with our other x's. But we can combine the 18x and the 12x into a 30x. And we've got the plus 4. All right, I hope this helps you with multiplying functions. Good luck.